All right, determine the points. So this is number 5 off the review. Sorry, number 5 off the review. Determine the points of the function that have a horizontal tangent line. Horizontal tangent line. So let's think ahead here. What are we after? Horizontal tangent line. That would have a slope of 0. That would mean the derivative is equal to 0. All right, so I'm going to take a derivative, set it equal to 0, and figure out what x values make that happen. Although it says points, so that means my answer needs to be x and y, not just x. All right, f prime is, right off the bat here, I've got a product rule. One that I think is simple enough that I will do the product rule in place, meaning I'm not going to write out f and g and f prime and g prime. I'm just going to know that the product rule is the first times the derivative of the second plus the second times the derivative of the first. Again, there's no shame at all if you need to write them out. F equals this, G equals this, like I did every time at the beginning. Then that's fine. If you need to see it and slow it down, and there's one of these that I'll still do that if it's more complicated, like the number 4. That's a product rule, but that's complicated. So if we do number 4, I will write it out because I don't want to try to do it all in place. But if you feel like it's straightforward and you can do it in place, then do it in place. Derivative of cosine is sine, except that it's negative sine. Kind of a common mistake on this type of problem is to get the hard part right and then just forget about the second part. It's like, finished the product rule, got it. But don't forget the rest of the equation. This one, kind of a rigged problem here because the sine x's cancel out. And so our derivative is just x cosine x. And we want to know where that's equal to 0. So if we think about factoring, when we set the factors equal to 0, this is not what factoring usually looks like, but that same thought process is there. We'll set both of the factors equal to 0. Because if x is 0, that makes the whole thing 0. And if cosine of x is 0, that makes the whole thing 0. So x equals 0 is one of my answers. Cosine of x equals 0, that would be, let's see, that's the x coordinate, so that would be pi over 2 and 3 pi over 2. Well, and this problem probably should have said on 0 to 2 pi. Because otherwise, there's an infinite number of answers to where is the cosine equal to 0. All right, we want points though. So I got the x values. So if x is 0, then f of 0. Back to the function, not to the derivative, but to the function because I want the y coordinate. So 0 sine 0 plus cosine 0. Testing our unit circle knowledge here. Cosine of 0 is 1, so 0 comma 1 has a horizontal tangent line. At pi over 2, f of pi over 2 would be pi over 2 sine pi over 2 plus cosine pi over 2. By the way, on a free response question, you could list all of that as your y coordinate and be fine because it's calculator ready, it's not calculus, and so you can kind of cheat your way around knowing your unit circle on the free response stuff. You can just leave your answer in terms of sines and cosines, and that's fine. Obviously, on a multiple choice test, it's not going to have that. It's going to expect you to figure this out. Sine of pi over 2, there's my picture already, is 1. Cosine of pi over 2 is 0. So pi over 2 comma pi over 2. And then lastly, if x is 3 pi over 2, I'll need to evaluate the function at 3 pi over 2. So back to the original function. Plug in 3 pi over 2 everywhere. Sine of 3 pi over 2 is negative 1. Cosine 3 pi over 2 is 0. So negative 3 pi over 2. So that function, there's 3 points that have a horizontal tangent line. Between 0 and 2 pi, there's way more than that, but we're not worried about those. By the way, you will have a calculator on the test tomorrow, or you can have one. It's just, there's only one problem that you need it on. The rest, I don't even know that it would help. I mean, I guess you could graph this and check to see if those look like they had horizontal tangent lines, but that might be more trouble than it's worth. Yes?
So for number